Hi everyone, one and all. In this module, we learn the concept of analytical chemistry, first semester's MSc, Karnataka State Open University, first semester. In this module, we learn the Unit 7 Gravimetric analysis. The contents of the units are the general principles and conditions of precipitation, concept of solubility, solubility product, and precipitation equilibria, steps involved in gravimetric analysis, purity of precipitates, co-precipitation and post-precipitations. The term gravimetry encompasses all techniques in which we measure weight or change in weight. In that gravimetric techniques, the precipitation gravimetry, electrogravimetry, volatilization gravimetry, percolate gravimetry. In this unit, we discussed only for that precipitation gravimetry or gravimetry precipitations. This gravimetry precipitation is an analytical technique in which the amount of analyte of a sample can be determined by selectively converting into an insoluble form by addition of a precipitating agent, means precipitant, to the solutions of the analyte. Once the formation of that precipitate, it is then undergo filtered, washed because to remove that impurities, and weighed as such after drying, or is weighed after ignition to another substance of known composition. From the weight and knowledge of its chemical composition, the weight of the analyte can be calculated based on gravimetric calculations and gravimetric as follows. Consider a simple chemical reactions. A is react with B, what we are getting here, AR. Here A is representations of analyte, R is a reagent, small a and small r is indicates that moles of analyte and r moles of reagent respectively. Once this analyte is react with that reagents to formation of a precipitate, this can be weighed as set after drying or can be ignited to another substance of known composition and then weighed. First we are going to find the percent of analyte, means weight of analyte 100%. Next, to calculate the weight of analyte WA from the weight of precipitate, These are all the parameters called gravimetric factors is often employed. The gravimetric factors means the number of grams of an analyte in 1 gram of a precipitate weight of analyte in gram. That is, WA is equal to weight of precipitate in gram into gravimetric factor. Here WA, gram of analyte present in W as gram of the samples. Then gravimetric methods, though time consuming, and provide precise and accurate results and have found wide utility in chemical analysis. What are the requirements for successful gravimetry? We are getting a successful gravimetry. The precipitation process should be sufficiently complete so that the quantity of analyte left unprecipitated is 0.1 milligram or less in determining major constituent of a macro sample. The substance weighed should have a definite composition and should be pure or very nearly so. Otherwise, error as result may be obtained. The precipitate should be sufficiently insoluble so that the amount lost due to solubility will be negligible. These are all the requirements for successful gravimetry. What are the steps involved in that gravimetric analysis? The precipitation techniques, digestion, filtration, washing, drying or incineration, finally weighing. These are all the techniques generally we adopted in the gravimetric analysis. Here the precipitation. The process of conversions of an analyte into its insoluble precipitate by adding suitable precipitating agent is called precipitation. In order to be gravimetric value, the precipitation process must fulfill the following conditions. What are the conditions for that precipitation? The precipitate must be formed quantitatively and within reasonable time. And the solubility of the precipitate should be low, enough for a quantitative separation to be made. The precipitate should consist of crystals of large particle size so that it can be filtered easily, as it will not the filter porous. And ideally the precipitate should have larger molecular weight so that errors in weighing may be reduced. As far as possible, conditions are to be made so that a precipitate specifically precipitates only one cations or anions in a mixture of ions present in the solution. These are all the conditions for that precipitation. What are the theories involving in that precipitation? The solubility product principle. When the ionic product of a compound exceeds its solubility product, precipitation occurs. The particle size and filterability of the precipitate. These are all the very important theories to involving in that precipitation titration. The particle size is one of the very important criteria to form a precipitate. The size of the particle of the precipitate play a prominent role in deciding the filterability of the precipitate. It mainly depends on two important events such as nucleations and particle growth which occur during precipitation. The nucleations means initial formation of the smallest particle of the precipitate capable of spontaneous growth. The smallest precipitate of the precipitate known as nucleus. The particle growth means the growth of initial nucleus by depositions of other precipitate particles to form a crystals of certain geometrical shape. Next, von Neumann's theory of relative supersaturations. The supersaturations means a stage at which the solution phase contains more of the dissolved solute than that in its saturated solution. It is a temporary condition and supersaturation stage is lost when precipitation starts. The relative supersaturation is defined as the these are all the selections conditions of precipitation from von Neumann's theory, in where Neumann's ratio should be made as small as possible. This is achieved by masking A low or B high. The conditions for masking A low. Dilute solutions are able to used to reduce supersaturation. The precipitating agent should be added drop-wise with stirring. The conditions for masking B is high, heating the solutions to an elevated temperature and thus carrying out precipitation in hot solution by adjusting pH of the solution and precipitating at low pH as possible by using complex forming agent. These are all the examples regarding to that. Next concept, homogeneous precipitation. This is a technique in which the precipitating reagent is not added but slowly generated within the solution by a homogeneous chemical reaction. As the solvent remains homogeneous with respect to both the ions of the reactant and the reagent at all times during the process of precipitation. Hence, the name the technique is called homogeneous precipitation. This process leads to both large and pure particles of a precipitate, minimizing the supersaturation. This technique involves two methods such as anion releasing method and cation releasing method. Both are discussed in that below slides. In that anion releasing method, slowly generated, which then combine with cations to form precipitate. Some of the examples of slow generations of anions acting as precipitant are given below. Generations of hydroxide anion. Hydroxide anions are generated by the hydrolysis of urea. Urea is what? It is a weak base. because the dissociation constant of weak base is 1.5 into 10 to the power of minus 14 and hydrolysis rapidly at 90 to 100 degrees Celsius. Generation reaction. The OH minus ions generated combines with aluminum sulfide, ferrous sulfide and TH4 plus. Here Al3 plus, Fe3 plus and thorium 4 plus to form precipitate of their hydroxides or basic salts. The hydroxides of Fe3 plus and Al3 plus are bulk gelatinous masses which are heavily contaminated and difficult to filter when they are formed by direct additions of base. In contrast, the same products are dense, easily filterable in pure form when they are produced by homogeneous generation of hydroxide ions. The rising the pH of the solution under the conditions calcium ions can be precipitated as a dense precipitate of calcium oxalate. What is the general reaction regarding to this? The dimethyl oxalate and dimethyl oxalate can be hydrolyzed to form oxalate ions which can be used to precipitate. Here generations of sulfate ions by hydrolysis of sulfonic acid or dimethyl sulfate, generations of phosphate ions by stepwise hydrolysis of dimethyl of trimethyl phosphate. These are all the common examples regarding to that anionic release method. Next we consider cation release method. In cation release method, cations are slowly generated when they combine with anions to form precipitants. An interesting example of this is the precipitations of sulfate by soluble barium EDTA 1:1 complex in the presence of hydrogen peroxide. What are the advantages of this cation release method? The precipitation from homogeneous solutions avoid high local supersaturations, which is the case when a precipitating reagent is directly added to the solution. By changing the rate of chemical reactions and producing the precipitate in the homogeneous solution, the required particle size of the precipitate can be obtained. Contaminations of the precipitate can be avoided. These are all what advantages of this cation release method. The contaminations of the precipitate. The gravimetric process is always contaminated with other ions present in the solution. The main causes of contaminations are co-precipitations and post-precipitation. Co-precipitations means the process by which a precipitate gets contaminated by substances which are normally soluble in the mother liquid is called co-precipitation. In that mechanism of this co-precipitation may be occur in more or one or more following ways: inclusion, occlusions and surface absorption. In that inclusions, it involves the random distributions of contaminated ions or molecules through the lattice sites of the precipitate. In that occlusion, the process ionic impurities get entrapped with the crystals. It involves the non-homogeneous distributions of contaminant ions or molecules within the imperfections of crystal lattice of the precipitate. In surface adsorption, it is a mode of co-precipitation involving adsorption of the contaminants to the surface of the precipitate. This process of adsorption is governed by the law Panette-Pezant's-Hall laws stated. What is the statement of this Panette-Pezant's-Hall law? It states that precipitate preferentially adsorbs that ions which forms least soluble compound with its lattice ion. For example, calcium oxalate preferentially adsorb magnesium ions more than sodium ions because magnesium oxalate is less soluble than sodium oxalate. Thus, ions adsorption is selective and it depends on the four factors. One is the nature of electrostatic attraction. Second one, concentrations of ions in solution. Third one, size of the ions. Finally, solubility as indicated by the Panette-Pezant's-Hall law. What is the illustrations of the surface adsorption? These are all the illustrations of the surface adsorption. The procedure minimizing the surface adsorptions are by washing the precipitate and by dilation. The next concept of this videos is post-precipitation. Sometimes when the precipitate is allowed to stand in contact with mother liquor, a second substance will slowly form a precipitate with the precipitating agent. The process by which an impurity is precipitated after the precipitation of the dissolved substance is called post-precipitation. What are the causes? Here, when an acid solution of ammonium oxalate is added to an acidified solution containing Ca2 plus and Mg2 plus. H2S is passed into the solutions of a mixture of Cu2 plus and Zn2 plus ions. What are the factors affecting post-precipitation? It's a temperature and time. It will increase at high temperature. Post-precipitation increases at high temperature. Post-precipitation is increases with time. What are the procedures for avoiding post-precipitation? The primary precipitate may be filtered off as quickly as possible. The acidity of the solution should be regulated and the ions likely to be post-precipitated should be protected by complex formation. It may be redissolved and reprecipitated as before. The additions of finely divided solids like silicosol, barium sulfate and broken glass reduces the post-precipitation. For example, post-precipitations of ZnS and CuS can be slowed down by the additions of Al3 plus ion or sulfur compound such as cystine. What are the comparisons between the post-precipitation and co-precipitation? The post-precipitation contaminations due to this increased time, contamination in that co-precipitation, contaminations due to this decrease with time. Contamination is enhanced on ignition in case of post-precipitation. It is not enhanced on ignition. It is in co-precipitation. Extent of contamination is large to post-precipitation. Extent of contamination is less compared to that. What are the errors in precipitation? Errors in precipitation. Errors means some deviate the value. In that, co-precipitated impurities cause either positive or negative errors in analysis. These are all the experimental procedure. Errors arising from the co-precipitations may be minimized in the following ways. The relative supersaturation is kept at low possible to ensure the formation of large crystals. Co-precipitated contaminants due to the surface adsorption are removed by washing with a liquid containing a small amount of volatile electrode. Contamination by occluded impurities in these crystalline precipitate is minimized by digestion. Digestion also helps in the formation of large coagulated particles instead of colloidal particles. The dissolving the precipitate and reprecipitating is helpful in minimizing the contamination. The precipitation for homogeneous solution is restored to keep the relative supersaturation is low. These are all the concept of error arising from the co-precipitation may be minimized. In that digestion means it is a process of allowing the precipitate to stand either at room temperature, at a low flame or on a water bath for a few hours along with mother liquor is called digestion. What are the reasons for digestion? Complete precipitation takes place. Granular dense precipitate be in a readily filterable form is obtained. Any contaminant which may be trapped along with the precipitate escapes and vapor crystals result. Promotes the formation of regular crystal shape with lesser surface area to the co-precipitations by adsorption would be less. If the precipitate is colloidal in nature, the Brownian motion prevents settling down the precipitate particles. Next concept, filtration. In that filtration, that's one of the very important technique. The process of separations of precipitate from its mother liquor, that is called what? Filtration. The most commonly used filters are sintered glass crucibles and goose crucibles, and quantitative filter papers, which are ashes shown as Wattman filter paper. These papers are manufactured in various grades of porosity of different types of precipitate. Very fine crystalline precipitate, slow, that is barium sulfate, gelatin or large crystals, Fe2O3.10H2O paused, small or medium sized particle, example silver chloride, it is in medium. That crucible, depending upon the nature of precipitate, various filters are used in filtration. For example, if the precipitate is to be simply dried and weighed, sintered glass crucibles are to be used. On the other hand, if the precipitate require ignition, has less filter paper are generally used. The precipitate collected in a filter paper or transferred into a silica or porcelain crucible for ignition. Also, washing of the precipitate. The precipitate usually carry impurities on their surface. That is filtered, means the water unfiltered, that is separate. In ideal quantities of washing liquid, it should not have the tendency to dissolve the precipitate, but have the tendency to dissolve the impurities adhered to the precipitate. The organic solvents like ethanol and ether may be used for washing. It should have no peptizing actions upon the precipitate. It should not undergo any chemical reactions with the precipitate. It should be dilute solutions of an analyte. The electrolyte used for washing the precipitate must be volatile at the temperature at which drying or ignition is done. These are all examples regarding to that. What are the types of wash solution? That is solution which do not allow the precipitate to become colloidal and pass through the filter. This tendency is observed in case of gelatinous or flocculated precipitates. The solution which have tendency to reduce the solubility of the precipitate. Finally, the solution which do not allow the hydrolysis of precipitate, which is a salt of weak acid and bases. What are the mode of washing? Using a set of wash liquid, the precipitate on the filter paper should be thoroughly stirred. A large number of washes with a small volume of wash liquid is more efficient to remove the impurities than a small number of washes with the large volume of wash liquid. If the precipitate is almost insoluble under hot condition, hot wash solutions are preferred due to the greater solubility of impurities and increased speed of filtration. What are the grain or incerations of the precipitate? The superficiality adhered water, occluded water present in cavities within the crystals or in the solid solution, absorbed water present on the solid surface. These liquids upon the humidity of the atmosphere. The essential water present as water of crystallization in case of calcium oxalate. What are the conditions for drying? Drying should be done at a temperature at which electrolyte associated with the precipitate completely volatilized. In the first case, the precipitate obtained after drying have no and definite composition so that it can be in weighable form. In the second case, the precipitate obtained after drying may not be in weighable form. What are the purpose of ignition? Suppose we consider the convert of precipitate into some other stable form of known and definite composition. The volatile, the electrolyte which needs elevated temperature to remove strongly adsorbed or occluded water, which is found mainly among gelatinous precipitate such as hydrated oxides of aluminum, iron and silicon. The temperature at which the precipitate should be ignited depends on the following fact. One is that weight. These are all the objective questions they mentioned. This is the fill in the blanks. If you go through that, here 1 mark question, 2 mark question, entire notes we have to mention here. Here, important questions are: mention how co-precipitation can be decreased, mention the remedy for post-precipitation, how would you prevent peptidation, what are possible errors in weighing, what procedure is adopted to remove occluded impurities, name the precipitate which can be ignited without drying or incineration, and gravimetric factor, peptidation, nucleation, and these are all the very important questions we got into that first semester's examination. In that, long answer type question is also very important. Here from this long answer type question, gravimetric analysis, precipitation, and advantages and disadvantages of this precipitation, co-precipitation and post-precipitation with examples. What is the remedy to this problem? Why is filtered precipitate washed? Why does a washed liquid generally contain an electrolyte? What is the requirement for such electrolyte? And precipitate from its mother liquor? And what are the various errors involved in precipitation, etc. These are all the Unit 7 Analytical Chemistry first semesters for Karnataka State Open University students. Okay. In each video we have to learn in that unit wise. Okay. Thank you one and all.